Let's talk about systems of inequalities. These are like a system of equations, but instead of having equal sign, instead of having that equation, it's going to be an inequality, which just means that we need to shade the graph in the direction of that inequality. So here's my first example. This says graph the system of inequalities, and you can tell that I have two inequalities that I'm going to graph here. And then I told you use y equals mx plus b to graph the line and then shade it appropriately. So all that means is I want to first graph both these lines using y equals mx plus b, the slope-intercept form. And then once I have those, I can check and see which direction I'm going to shade. So for the first line, I'll do this one in blue. Here the y-intercept is -3, so let's start down here on the y at -3, and the slope is 4, so I'll be going up 4 over 1. But notice that this is just a greater than sign. There's no equal to on the bottom. So when I count this up 1, 2, 3, 4 over 1, when I go to connect the dots to make the line, I'm actually going to have a dashed line because the line itself is not included in the inequality, right? Y would only be greater than this. It's not greater than or equal to, it's only greater than. So I'm shading up from this since y is greater than this. I would just sort of shade up from this line. If it was less than, I would shade down, but it's greater than. So kind of everything on this side of that line would be included. We also have to graph the other line. So again, I'll use the same thing, y equals mx plus b, the slope-intercept form. Here the y-intercept is 3, positive 3 up here. And the slope is a -2, which means I'm counting down 2 over 1, down 2 over 1. Just like that. You can see they intersect right here at that dot, down 2 over 1. And on this one, I am going to use a solid line because the line is included in that inequality. I have this little line underneath the greater than. So y is greater than this, and it's also equal to, means I want to use a solid line for that. And again, y is greater than this, so I'm going to shade up from this line. And this means that the solution to this system is where these shades intersect. So here and here is where the shades meet. So let's color this in. Red and blue makes purple. So I'm going to shade this in with purple. So basically anything inside this shaded area would be a solution. And just notice this goes off the graph too. It would keep going up this way. It would keep going up that way. This also goes off the graph, infinity, anything inside of that shaded area. Let's look at a harder one. So this is going to be a little more difficult because these are not already in slope-intercept form. So the first thing that I have to do is actually just move some stuff around to put these into that y equals mx plus b form. So like here on the first equation, the first thing I would do is move this x term over by subtracting it over to here. So I'm going to have -3y is less than -4x, I'm subtracting that over, minus 9. All right, and then I just have to get rid of this -3 that's multiplying the y, and I'll do that by dividing both sides by a -3. And remember, when I divide by a negative number, it's going to flip this sign. So instead of less than, this is going to be a greater than sign. -4 divided by -3, that's going to be a positive 4/3 x, and then -9 divided by -3 is going to be a positive 3. All right, so now I can graph this pretty easily now that I've put that into slope-intercept form. I'm going to do the same thing for this one on the bottom as well. So again, let's just start by moving this x term over by subtracting that over. So that'll give me 3y greater than -x plus 6. And then to get rid of this 3 that's multiplying the y, just like before, I'm going to divide that out. And here I don't have to flip the sign because it's not a negative number, but I'm still going to divide that. So it'll be y is greater than, and again, not flipping the sign here, negative 1/3 x. So this is negative 1/3 because I had a negative invisible 1x, and then dividing that by 3, negative 1/3, and then 6 divided by 3 is going to be 2. Okay, I see a mistake that I made here in the green equation. So this was a positive 9, which means that when I divide that negative 3, this should be a negative 3. Okay, so now that these are both in slope-intercept form, y equals mx plus b, now they're pretty easy to graph. The y-intercept for this is a negative 3. And then the slope is going to be rise over run. So 4/3 means I'm going up 4 over 3. 1, 2, 3, 4, up 4 over 1, 2, 3. Just like that. This is also going to be a dashed line, just like the one before. It's dashed because it doesn't include the line. It's just saying y is greater than this line. So as I go to connect these dots, I'm just going to use a dashed. All right, and then I'm shading here, y is greater than this, so I'm shading everything that's greater, shading up from here, greater, greater, greater. All of this. And let's do the purple line also. So here, the y-intercept is a positive 2. The slope is negative 1/3, so I'm going negative 1, down 1, and then over 3, down 1, over 1, 2, 3. You can see they're going to intersect right there. And then again, I'm using a dashed line for this because the inequality is not including the line. It's just everything greater than this line. There we go. And I'm shading everything greater than this line, just like that. So again, just like on the last one, our solution is going to be where these two shades intersect. So kind of this upper area up here. I would shade all of this in on my paper. And again, it's important to notice that this goes off the graph as well. It goes up in this big cone. So everything up here, infinity, you could use any of that as a solution.